Hello students, we shall see the third unit of advanced inorganic organic chemistry, that is photochemistry. So first, as your syllabus, introduction of electromagnetic radiation with matter. So here we shall see what is the interaction between, that is, light and matter. So in this diagram you can clearly see how the radiations have been classified into different radiations. That is, spectrum is classified into here: cosmic rays, gamma rays, X-rays, UV, visible, IR, microwave, and radio frequency. So here you can see. So below it is a clear picture is given. So as you go from cosmic rays to radio frequency, the wavelength decreases, and vice versa the frequency. That is, frequency decreases, wavelength increases. From cosmic rays to radio frequency, frequency is measured in hertz, wavelength is measured in nanometers. Frequency decreases and wavelength increases. So right below it is given how the notations are used: change of electron distribution, change of configuration, C change of orientation, and change of spin. Now we shall see how this changes occurs. So there are two, whenever there is interaction of electromagnetic radiation with matter. So we shall see the light, that is, light when it interacts with matter, it acts as a dual nature. One is wave nature, another one is particle nature. So here, according to the Maxwell's theory of electromagnetic radiation, we know that light travels in space in form of oscillating electric field. So this field is generated by acceleration or deceleration of charged particles, which act as source of radiation. If particles moves with a steady speed, field due to the charge will follow the motion and medium will be undisturbed. But if there is acceleration, the field will not be able to follow the change. A disturbance will be generated and propagated in space. So this variation of field strength as a function of time and space is given by the expression Ey is equal to E naught sine 2 pi Vt minus x by lambda, where Ey is electric field strength vector in y direction, and E naught is a vector constant in time and space. Right here it is given lambda is wavelength in nanometers, mu frequency, A is amplitude of oscillation at any point A. So right, by using suitable devices, radiation plane polarized in air can be obtained. A combination of two wave tranches polarized in different places give rise to linearly elliptical or circularly polarized radiations when certain phase relationships are satisfied. So some of the symbols are given below, so which can be used for further explanation. So this is one is wave nature of light. Here it is clearly given how this wave transits from one point to another point. So an oscillating electric field E generates a magnetic field H at right angles to itself as well as to the direction of propagation. The magnetic field oscillates in phase with the electric field, and magnetic vector is directed perpendicular to the electric vector. The variation of this magnetic field strength is given as, so Hz is equal to Ho sine 2 pi Vt minus x by lambda. So here you can observe, so we have already taken the variation of field strength, electric field strength in Ey is equal to E naught sine 2 pi Vt minus x by lambda. So now in place of E, so which generates magnetic field, we are substituting H. So this gives Hz. So this you can see in this figure how this it is known. Ey is above vertical, Hz it is below this Ey, it is perpendicular to the Hz is perpendicular to the Ey, that is at right angles. So amplitudes also for two fields are related as H naught E naught by H naught is equal to uh, mu by square root of mu by E, where mu is magnetic permeability and E is the dielectric constant of the medium in which radiation is propagated. So right, this is one wave nature. Particle nature, as we know, a particle is defined by its mass and its momentum P or energy E. The particle of nature of light is visualized in the form of a wave, packet or quantum of radiation whose energy is given by relation E is equal to h mu, where h is Planck's constant 6.62 into 10 to the minus 34 joules second. One quantum of radiation is called photon. The energy of photon is given by E is equal to mc square, where m is mass of photon and c is velocity of light in vacuum. Combining these two equations, we get mc square is equal to h mu, or mc is equal to h mu by c, that is equal to momentum of photon. From theory of relativity, the rest mass of photon is 0. So right, using this we can see the dual nature of matter. So understanding basic nature of matter is limited by Heisenberg uncertainty principle. The principle implies that our measurements of position and movement of particle of subatom are always in error when radiation is used to study matter. That is, according to Heisenberg's uncertainty principle, you cannot determine both position and momentum of a particle simultaneously or at a time. So right, if delta x is on this basis, if delta x is error in the location of particle and delta p is inherent error in the measurement of its momentum, such that product delta x delta p is so approximately equal to h, where h is Planck's constant. If delta x is made small, delta p becomes large and vice versa. Similarly, energy and time from a conjugate pair given delta E into delta t approximately equal h. The principle, so according to this, so when you substitute, you get lambda is equal to h by p, that is equal to h by square root of 2m E minus v, where E is total energy and v is the potential energy. So an expression for describing such a wave motion was obtained by Schrödinger in 1925. Schrödinger equation is second order differential equation which can be solved to obtain the total energy of dynamic system when expressed as a sum of kinetic and potential energies. That is minus h square by side pi square m d square by dx square plus dx square by dy square plus d square by dz square into psi plus v psi is equal to E psi. So as we know, this is a common Schrödinger wave equation. So minus E by h by 8 pi square m v, that is delta square, plus v into psi is equal to E psi. So this gives nu psi is equal to E psi, where delta square is equal to d square by dx square plus d square by dy square plus d square by dz square is equal to a Laplacian operator. So this gives v is equivalent to Vx plus Vy plus Vz, that is potential energy operator. So nu is equivalent to minus h square by 8 pi square m delta square plus V is equal to Hamiltonian operator. So in this equation, psi is known as eigenfunction and E the eigenvalue or characteristic energy value for corresponding to this function. On solving the equation, number of values for xi such as xi0, xi1, xi2, xin are obtained. So corresponding to each eigenfunction, there are characteristic energies E0, E1, E2 and Etn. Thus an electron constant to move in potential field can have only definite energy values for its motion. So it is governed by the condition that motion shall be described by a standing wave. So thus by using wave nature as well as particle nature, we can come to the value of nu is equal to minus h square by 8 pi square m delta square by v. So there are some electronic energy states of atoms corresponding to these organic molecules. So here you can see, so if you take a hydrogen atom, it has single electron. So this can be expressed in coordinates as polar coordinates r, theta and psi. Psi r theta psi is equal to capital R into r, psi into theta, that is and it is psi into small psi. So the solutions for these are theta, theta, theta and psi into phi equations introduce the three quantum numbers n, l and m, which have integral values required by the quantum theory. These quantum numbers are: one is n, principal quantum number indicates energy state of system and is related dimensions of the orbital. An orbital of number n will have n nodes including 1 infinity and n can have values for 1, 2 and 3. So L is azimuthal or orbital quantum number. Angular quantum number arises due to the motion of electron in its orbital. So angular momentum is a vector quantity whose value is given by square root of L into n plus 1 h by 2 pi. So this quantum number is related to the geometry or shape of the orbital and is denoted by symbols s, p, d, f, etc. corresponding to L values of 0, 1, 2, 3 respectively. The possible values of L are governed by the principal quantum number n such that maximum value is n minus 1. Right? When n is equal to 1, L is equal to 0, n is equal to 2, have L is equal to 0, 1, and n is equal to n, you have L is equal to 0, 1, 2, and to n minus 1. For the H hydrogen atom, the set of L values for a given n orbital have same energy, that is, they are degenerate. The square of angular momentum are eigenvalues of the angular momentum of operator L square. So L square xi n L plus or minus m is equal to L into L plus 1 h square by 4 pi square xi n comma L plus or minus m. So m, the magnetic quantum number, defines orientation of ion in space and is effective in presence of externally applied magnetic field. So it corresponds to the component of angular momentum in the direction of field. In the absence of field, each orbital of given value Cn and L, that is 2L plus 1, fold degenerate and can have values of 0, plus or minus 1, plus or minus 2 up to plus or minus 12. L. The magnetic momentum quantum numbers are eigenvalues of the operator Iz such that Iz psi is equal to plus or minus m h by 2 pi xi. So another very fundamental which has to be included for a system with more than one electron in is the spin quantum number. A spin quantum number arises due to the spinning of electron on axis defined by existing magnetic field. This generates an angular momentum which is vector quantity of magnitude s into s plus 1 h by 2 pi. S can have only two values, plus or plus half and minus half, since it is assumed to be an intrinsic property of the electron. The concept of spin quantum cannot be deduced from the Schrodinger equation. So as according to the Pauli's exclusion principle, no two electrons can have same value for all quantum numbers. If n, l, m values are same, then two electrons must differ in their spin. For example, for a normal hydrogen atom with two electrons having quantum numbers n is equal to 1, l is equal to 0, m is equal to 0, one electron shall be in s is equal to plus half state and another in minus half state. On the other hand, for an electronically excited hydrogen atom, since now two electrons reside in two different energy states, its n values differ. The two electrons may have the same spin values. The wave function for a spinning electron is therefore written as psi is equal to psi n l m into sigma s, where psi is space dependent function, sigma depends on the spin coordinates only. Normally, sigma plus half is designated as alpha and sigma minus half is designated as beta functions. So these are given in the next picture. So which how these symbols are used. So you can see at the right, m is equal to 0 for 1s orbital. So when m is equal to 0 for 2p orbital, you have two values, m is equal to 0 and m is equal to plus or minus 1. And what are the probable shape of orbitals? That is radial spherical distribution functions for atomic orbitals are given. If it is 3D, then m is equal to 0, so you have 1, m is equal to plus or minus 1, and then you have m is equal to plus or minus 2.